Okay, this recording is to show you guys how to find the inverse of a function, and then once you find the inverse, how to prove that your inverse is right, or to prove that it's right. So here's the function: f of x equals 2x cubed plus 1. So we're going to follow the 4 steps that we've always followed in class, where we change the f of x to y. So that becomes y equals 2x cubed plus 1. And then the next step is to solve for x, to leave x by itself. So the first thing I'm going to do is subtract a 1. And so I have y minus 1 is 2x cubed. Okay? And so again, keep in mind your goal is to leave x by itself. So I'm going to divide both sides by 2. Okay? And so on. So now let me clean it up. So let me just write it. Y minus 1, this is what we have so far. Y minus 1 equals x cubed. Okay? So again, we have left x by itself, except it's not just x, it's x cubed. So to undo the cube, we take the cube root of both sides. Okay, remember it's an equation, so whatever you do on one side, you have to do on the other. So now I have the cube root of y minus 1 over 2 equals x. Okay? And the third step, so now we've isolated the x, we've left it by itself. The third step is to switch the x and the y. So I'm going to go to the next column over here, switch the x and the y. So I've got cube root of x minus 1 over 2 equals y. And the fourth and final step is to replace the y with the function notation. Okay, so we're going to write, and then I'll just write it on the left side. So f inverse of x equals the cube root of x minus 1 over 2. So according to my work, this is what I have as an inverse. Okay, so now I'm going to show that in fact it is the right answer. Okay, so step number 1 is we're going to do function composition, and the first one we're going to do is f of f inverse of x. Okay, so basically what this means is that we're going to take the f of x function, and we're going to replace the x's in that function with f inverse of x. Okay, and remember, f inverse of x equals this right here. Okay, so I'm going to go up to the top here. This is my f of x up here. Okay, so I'm going to write, and I'll just put an equal sign here, 2, and in class I usually leave a big blank spot like this to emphasize the fact that yes, I'm going to be filling in this spot right here with f inverse of x, which in this problem is this. Okay, so I'm going to put the cubed root of x minus 1 over 2 in there, and then simplify. So we have to follow the order of operations. So the first thing we're going to do is take the cube root of a cube, or cube the cubed root. So that means that this part right here is the first part that I'm going to simplify. Okay, so that leaves me with 2 times x minus 1 over 2 plus 1. And so then the next step after that is the 2 and the 2 reduces to 1, and then I'm left with x minus 1 plus 1, and so the 1 minus 1 is also, that becomes 0, and so I have x. Okay, so we're halfway there. Now you have to do the other direction, the other composition. We're going to do f inverse of f of x and see what we get there. So now we're going backwards. So now I'm going to start off with this function right here, f inverse of x, and wherever I see an x, which is right here, I'm going to replace that with my original function, with f of x. Okay? So let's just follow along. So right here, and I'll do it on the next line just because this is not enough, the right side is not enough space, I'm afraid. So I'll just start right here. Let me draw this line to separate the two sections. So f inverse of x is cube root of, and I'll just make a big radical symbol. And in place of the x, I'm going to put a big set of parentheses with a big, a big empty spot there, over 2. Okay, so now remember, I am going to fill in this empty spot right here with f of x, because that's what this is telling me to do. It's telling me take f inverse and replace all the x's in f inverse with f of x. Okay, so this is f inverse, and in place of the x, I'm going to replace it with f of x. Okay, so now I have 2x cubed plus 1. And then again, order of operations, we go step by step, use the order of operations. So cubed root of, now the 1 minus 1 cancels, and you're left with 2x cubed over 2. The 2 over 2 becomes 1, and so then you're left with the cube root of x cubed, which equals x. Okay, so with by getting x in both directions, you have proven that your answer for the inverse is correct. Okay, so you could say something along the lines, both equal x, therefore my inverse is correct. Okay?